Hello, this is Elimu TV and my name is Mr. Kamau and I'm teaching today mathematics for Form 2 in preparation for the Kenya Certificate of Secondary Education. In today's lesson, we are going to learn cubes and cube roots. And in cubes and cube roots, we first of all remind ourselves what we learned about squares. Now, what is a square? A square of a number is a number that is multiplied by itself twice. So if I say the square of 4, that means 4 squared is equals to 4 multiplied by 4. And this gives me 16. If I say the square of 3, that means 3 squared. And 3 squared is equals to 3 multiplied by 3, which gives you 9. Similarly, when we talk about cubes, a cube of a number is that number multiplied by itself 3 times. So, if we take a cube of 3, for instance, you say 3 cubed is equals to 3 multiplied by 3 multiplied by 3. And we know that this gives us 27. The cube of 4 is 4 cubed, and the notation is 4, then slightly above in front of the number, you write the superscript 3. So 4 cubed. So don't write it as 4 3. If you write it that way, we will read it as 43. It should be 4, then slightly above to power 3. So 4 to power 3 is 4 cubed. And that means 4 multiplied by 4 multiplied by 4, which will give us 4 by 4 is 16. 16 by 4 is 64. So in general, we can say that the cube of a number x, where x represents any number, is x cubed. And that means you multiply x by itself 3 times. 1 time, 2 times, 3 times. So that is the definition of a cube. If you are told, find the cube of 11, that means 11 cubed. This will be equals to 11 multiplied by 11 multiplied by 11, which will be equals to 11 multiplied by 11 is 121 multiplied by 11, which will give us 1,331. We can now say the cube of 11 is 1,331. To emphasize the cube notation, we are told, write the following. Write the following using the power 3 notation. So, what is 3 times 3 times 3 in power form? What is 7 times 7 times 7 in power form? And what is n times n times n. I know you already have the answer. The first one will be written as 3 to power 3. Or of the second one, you got it, 7 to power 3. Third one, it is n to power 3. So that notation is very important so that we don't confuse a digit 3 and a power 3. It's very, very important. Now, I would like you to evaluate the following. Number one, what is 2 to power 3? What is 2 to power 3? Number two, what is 10 to power 3? And thirdly, what is 43 to power 3? Work that out on your own. I'm sure you get the correct answers. Let me just give them to you straight away. 2 to power 3 means 2 multiplied by 2 multiplied by 2. That should give you 8. Whereas 10 times 10 times 10 is equals to 1,000. This is 43 multiplied by 43 multiplied by 43. 43 multiplied by 43 is 1,849. Multiply that by 43 and the final result is 79,507. Did you get all of them correct? We now move on to another method of using getting the cubes of numbers. Cubes using tables. Now, what tables am I referring to? I'm referring to the mathematical tables. You should be able to have this. We have special mathematical tables that are endorsed by the Kenya National Examinations Council. They are of different colors. You can find them in the local bookshops. Now, in that table of cubes, the tables give us the cubes of numbers between 1 and 10 only. For numbers greater than 10 or less than 1, you will have to write the number first in standard form. So, for example, you are told use tables to find number 1, 3.472 cubed. Number 2, 12.71 cubed. And thirdly, 0.06443 cubed. Notice I have given you a number that lies between 1 and 10, which you can get straight away from the mathematical tables. And then this one is a number that is higher than 10. So we need to find out how do you get the cube of a number that is greater than 10 from the tables. This one is a number less than 1. So we also need to find that out. And so other than numbers that are in this bracket between 1 and 10, how do we get the cubes of numbers of all other numbers? Now, I will take you through a process of doing that from the maths tables. And so I would like you to follow me very keenly. I advise that you must have the mathematical tables with you in order to follow me on this. Now, on the mathematical table, which you have, you will find, let me open to that page on my mathematical table. You will find the first column on the table. So you have that, then you have other columns here, and then we have smaller columns. We have smaller columns. We have this, this is the first column. Then after the first column, we have this headed as, we have this is column 0. I call them major columns, column 1, 2, all the way up to column 9. And then on the other side, we have the minor columns. We have starting from column 1, 2, 3, all the way to column 9. So we have major first column, which we can call X column. Let me call it X column. Then we have major columns from 0 to 9. Then we have minor columns 1 to 9. I hope that is clear to you so far. Now, when we want to find the cube of 3.472, we will go to column X and look for the number 3.4. You will find it there, 3.4. So now that is, it has a row of numbers all the way through the major columns to the minor columns. Now, how do we use those numbers? The major columns help us to get the cube to the second decimal place. So if we look at our number, our object number, it is 3.472. So far we have 3.4. Now we need to find 7. So we move along this row to major column 7. So along this row, at major column 7, you find a number there, and that number is 41.782. So you have 41.782. Now that is telling us that the cube of 3.47 is 41.782. But we are interested with the cube of 3.472. So the next thing we do is, from there we now have 7, we need 2. To get this 2, we go to the minor columns and we find column 2. And under this column, still along the row number 3.4, you find a number there, and that number is 71. So what do we do with the 71? We go back to our 41.782 and we add, because it says on the minor columns it says add. So we add 71 and do the total. So this becomes 35814. So there is our answer. The cube of 3.472 is 41.853. Did you get it? We'll go to the second example to clarify that procedure. So coming to the second example, we have 12.713. Now, what we said is that this number is beyond 10, so we have to write it first in standard form. So this number, 12.71, in standard form can be written as 1.271 multiplied by 10 to the power 1. So we are going to find the cube of all that. Now we follow the same procedure as before, because this one, when you open the bracket, it becomes 1.271 cubed multiplied by 10 cubed. So from the tables we can get this following the same procedure. That means go to column X and find 1.2. Move along that row, the row 1.2, until you come under major column 7, the third decimal, the third significant figure. So there we are. And what number do you find there? Whatever number you find there, so that will give you the number to work with. So at 1.27, we have the number 2.048. I hope you are getting the same thing. So we have 2.048. Now we need the third decimal, the fourth significant figure, which is 1. And so that one we get from the minor column, and here at the minor column 1, we will find the number 5. So that is the number that we add, 5, and the result that we get is 2.053. 2.053. So therefore, our solution becomes 1.271 cubed, which is 2.053 times 10 to power 3. That means times 1,000. And so the final result will be 2053. And so you can see the procedure. It is possible to get the cube of a number that is beyond 1 by actually, first of all, writing this one in standard form before we get the cube. Now, since our time is up, I will like to stop this here, and in our next lesson, we'll continue and find how to get the cube of a number less than 1. So thank you for listening. You've been a good audience, and I believe you will do more practice on cubes and how to use tables, how to use multiplication to get cubes of numbers. So thank you, and bye-bye.